Okay, we're going to take a look at section 3.6 on molar concentration, and I'm going to share my screen with you so you can see my textbook. And let's take a look at page 136. And I want to do the warm-up. It says, list 3 products in your refrigerator that are solutions. Well, soda is a solution, and so is apple juice, and so is vinegar. Name some substances that are dissolved in these solutions. Well, we've got some vitamins, and we've got some salts, and we've got an acid dissolved in vinegar, acetic acid. And where else in your home are solutions kept? Well, sometimes you might keep them in the garage or under a sink, or they might be in a bathroom. Okay. And we're going to be talking about molarity today, which is a very useful concentration of a substance. So concentration is an expression of the amount of a chemical in a solution. So when they say proportion, they mean the amount. Okay. And it's really important for chemists to know how much of a substance is present in a volume of a solution. So when we're talking about concentration, we're typically talking about the amount of solute per volume of solution. And there are a lot of different units for concentration. Some of the common units are going to be things like grams per liter, the parts per million. And the most useful unit for concentration that chemists use is the quantity of solute in moles. And we're going to be using something called molarity, which is a capital M. This is the moles of a chemical per liter of solution. And so when you see something that says 1.8 capital M HCl, that means 1.8 moles of HCl in a liter of solution. And this right here can be written as 1.8 moles of HCl in 1 liter, okay? Or you can write it as a fraction, 1.8 moles of HCl over a liter. Or you could flip it, 1 liter on the top, 1.8 moles of HCl on the bottom, okay? And they show you that in the example down here. So if you have 3 capital M HCl, this is often referred to as molar HCN. You can write that as a liter of solution equals 3 moles of HCN, or I could use it as a conversion factor, which is a fraction, written each of these ways, okay? There is also something known as the Molarity Triangle. So molarity would be your capital M in the bottom left, moles on the top, and liters on the bottom. So if you're going to solve for molarity, cover up that M, and it tells you to take moles and divide it by liters. If you're going to solve for moles, cover it up, you're going to take molarity times liters. If you're going to solve for liters, cover it up, and you're going to take moles divided by molarity. You also know that grams can get converted to moles by dividing by the molar mass. And we can convert moles to grams by multiplying by the molar mass. And if you ever have something in milliliters like 123 milliliters, That's the same thing as 0.123 liters. You can just move the decimal 3 places to the left. Okay? Take a look at the next page at the quick check. It says, give one reason why solutions are important in chemistry. Well, many chemicals are dispensed in solution. Okay? And what does 2 molar NaOH mean? This means there are 2 moles of NaOH in 1 liter of solution. Why is molarity a useful unit for concentration? Because it actually allows chemists to compare the number of particles in the same volume. Okay. Now, if you want to, you can use this as a guide. If you're converting moles to liters, then you would multiply by 1 liter over however many moles you've got. If you're converting liters to moles, you would use this fraction to convert. But what I'm going to do is I'm going to go ahead and show you on the next page how to do some of these problems. But before that, let's take a look at the sample problems. The average salinity of seawater is 0.6 molarity. How many moles of salt are in a bucket with 435 milliliters? If you're solving for moles, use the molarity triangle back here. Cover up moles, it tells you to take molarity times liters. So you're going to take this 0.60 molarity times, remember 435 milliliters is the same thing as 0.435 liters. And then you're going to end up with 0.26 moles as your answer. Okay? Now, what if we're doing a different type of sample problem, like this one down here, where they want to know the volume of 3 molar HCl that somebody has to dispense to obtain 0.25 moles. If you're solving for volume, come over here to the molarity triangle, cover up the L. You're going to take moles divided by molarity. So that means liters is moles divided by molarity. So it's 0.25 moles divided by 3 molarity. And you're going to end up with 0.083 liters of solution. Let's turn the page. Take a look at the practice problems here. Here they're asking you to solve for moles. So cover up moles in the molarity triangle. This is going to be molarity times liters. Multiply those two together. You're going to get 1.8 moles. For number 2, an IV bag of saline contains 0.154 molar NaCl. How many moles of NaCl does 500 milliliters contain? Cover up the moles in the molarity triangle, multiply molarity times liters. Take 0.154 molarity times, convert this to liters by moving the decimal over. And you're going to end up with 5.0, actually, not that large. It's going to end up being 0.0770 moles. Okay. For number 3, they gave you moles and molarity and want you to solve for liters. Cover up the liters in the molarity triangle. Take moles divided by molarity. So this is 3 moles divided by 0.60 molarity. And this is going to end up being 5.0 liters. Okay? Okay, now let's talk about preparing a standard solution from a solid. Anytime you have a solution that the concentration is known, it's called a standard solution. It's important that you know how to prepare a standard solution. So typically what you do is if you have a solid, you have to calculate how much of that solid you have to measure out, put it in a container, and then you add water up to whatever the volume is that they're specifying. So if you want to prepare a 1 molar sodium chloride solution, you need to measure out the mass of sodium chloride, and then you're going to add water up to the 1 liter mark, because 1 molar specifies 1 mole of sodium chloride in 1 liter of solution, okay? But you can't just tell me, oh, you need to go measure out a mole. Well, I need to know what mass that is. So in order to get that, you would have to go to the periodic table and you would have to look at those molar masses. Your sodium is 22.99. Your chlorine is 35.45. So you have to add those two values together, which is going to end up giving you 58.44 grams. So you would have to tell me, I'm going to measure out 58.44 grams of sodium chloride. Then I'm going to add water up to 1 liter. Okay, you don't add a liter of water, and the reason is because the sodium chloride is going to dissolve a little bit in it, and it's going to occupy a little bit of volume. So it's going to make the volume a little bit larger than what you would expect it to be. So you first dissolve a little bit, and then you go up to the 1 liter mark. Okay, and that's because down here they tell you, because the solute will displace a small amount of water, that means it will occupy a small amount in terms of the volume. Okay, so if you take a look at the sample problem down here, it says describe how to prepare 0.055 liters of 0.20 molar KCl from the solid. So if you're using the molarity triangle, you need to solve for moles and then convert that to grams. So cover up moles, take molarity times liters. So it's 0.20 molarity times 0.055 liters. That's going to give you your 0.2 times 0.055, 0.011 moles of KCl. Then you have to multiply that by the molar mass to figure out how many grams are needed. So 0.011 moles of KCl. The molar mass will go up here. You get that from the periodic table. Potassium is 39.10, chlorine is 35.45. So this is 74.55 is your molar mass times 0.011. That's going to be 0.82 grams of KCl that you have to measure out. And then you're going to add water up to, if you move the decimal over 3 places, that's 55 milliliters. So you add water up to 55 milliliters. And that's how you would make that solution. Okay. Okay, if you take a look at the practice problems on the next page. Here it says, describe how to prepare 500 milliliters of 1.5 molar from calcium chloride solid. So again, you're going to have your molarity triangle. So you're going to take your 1.5 molarity times 0.5 liters. That will give you your moles of calcium chloride. Then you're going to take your moles of calcium chloride and you're going to put the molar mass on top here. I need the periodic table for that. So calcium is 40.08. Chlorine is 35.45. You're going to get 83 grams. So you have to measure out 83 or whatever, 83 grams of calcium chloride, then add water up to 500 milliliters. That's how you would prepare that, okay? And then number 2, what's the molar concentration of silver nitrate? If you have 1.8 grams and you add water to 75 mils, you have to convert grams to moles by dividing by the molar mass. And then after you get that, you will divide by 0.075 liters to get the molarity. And the number that goes here is the molar mass of silver nitrate. And you're going to get 0.14 molarity as your concentration of that solution.
Good afternoon, everyone. This is Sister Joni, and I have a very important message to all of the students. I know that your favorite thing of the whole year is selling those wonderful raffle tickets. This year, it's absolutely important